Hello again, and welcome to this next lesson about similar right triangles, which is lesson 9.4. For this lesson, you are welcome to use a calculator to make any calculations. Now first, let's go over some vocabulary. So in this lesson, we will be working with an altitude. And an altitude takes a big right triangle, starts at that right triangle, and is drawn towards the hypotenuse. And as you can see, it cuts the triangle into two pieces. Not necessarily in half, but two pieces. So let's look at this theorem here. If the altitude is drawn to the hypotenuse of the right triangles, which is right here, then the two triangles formed are similar to the original triangle. This means that this big triangle is similar to these smaller ones. So this one and this small triangle here. So let's look at example 1. So example 1 gives us a big right triangle that has an altitude, CD. And for letter A, it says sketch the 3 similar triangles, label the vertices. Okay, so our first triangle here is ACD. So let's draw that here, A, B, C. And just take note of what sides are the shortest and the longest. So we know that AB is our hypotenuse, which is the longest side, and CB is the shortest. Okay, and this will help us draw the other triangles as well. So let's do our second triangle, which is ADC. So our right angle is D, C is here, and A is here. So here, CD will be our short side, and AC is our hypotenuse. So I'll abbreviate there. Okay, now let's draw our third triangle, which is CDB. Okay, D is our right angle, C is up top, and B is on the side. Now our short side here is DB. And our hypotenuse is CB. Okay, now in letter B, we want to write the similarity statements for the three triangles. So let's start with the first triangle. Our first triangle is ABC. Now remember, when we're writing similarity statements, the order matters. Okay, so we have to make sure that the corresponding sides are listed in the correct order. So first we labeled ABC. So that means we went from the hypotenuse to the short side. So for the other triangles, we have to start at the hypotenuse and work towards the short side. So for the second triangle, we would start at A, go to C, and then go to D. So we would have ACD. And then the third triangle would be CBD. All right, now I'd like you to try it. So look at triangle QRP, sketch the 3 similar triangles, label the angles. Here I've drawn the 3 similar triangles. Now let's just label them a bit. So this would be the hypotenuse for all of them, and then we'll label the short side as well. Short side for the first one is RQ. Short side of the second one is QS. And short side of the third triangle is RS. Now I'd like you to do B. Write the similarity statement for the three triangles. Okay, here I've written the similarity statement for the three triangles. Now, your letters may be out of order. However, if you have the sequence, it should be correct. So you could also have PRQ or QPR. And then, of course, the rest of the statement should be corresponding to that. All right, very good job, everyone. Let's move forward. Now, in this part of the lesson, we are going to work through this elevator. Okay, now when you have an altitude in a right triangle, because the sides are similar, that means we could find missing sides using proportions, just as we started using in the previous lesson. Okay, now as you can see in the previous part of our lesson, like drawing all the similar triangles takes a bit of time. So this elevator theorem takes us to a shortcut that helps us find missing sides in these right triangles with altitudes. So let's walk through it. So the elevator theorem, you have to have an altitude. Okay, so this could be a number or an x. So x or a number. So as long as you have that altitude value or you're trying to find that value, you could use this method. So this elevator theorem is kind of like a story. So we start outside and we want to get outside the building after we go to work. Okay, so we go inside the building. Our office is up here. So we take the elevator up to our office. We work for a few hours, then we take the elevator back down, and then we go out here to have some lunch at a restaurant. Okay, so how does this relate to our similar triangles? Well, if we go in the building, this will be the numerator of our first ratio. Then we go up the elevator, and this should equal us going down the elevator and then out the back door. Okay, so let's try to apply it to a problem. Let's try example 2. So we want to find the value of the indicated length. Well, here we have a right triangle, and we're also trying to find this altitude. Well, again, remember our altitude is the elevator, so we could use elevator method. So we start here on the left. We go inside the building, that's 7. We go up the elevator to our office, and that's x. After we work for a little bit, we want to take our lunch break, so we go down the elevator and have an x. And then we go out the back door to get some food, which is 9. Now from here we could solve for x. So what we want to do is cross multiply. So we have x times x, which is x squared, equals 7 times 9, which is 63. Then we square root both sides. On the left, the square root and the square cancel out, so we have x. And then square root of 63 can be simplified, because if we prime factor, we would have 9 and, we would have 9 and 7. 9 can be prime factored into 3 and 3, which can come outside our square root. So x is equal to 3 square root 7. Okay, let's try one more problem together. We're looking at example 2b. Now here our triangle is kind of slanted, but we have to identify if we have our elevator first. And we do, which is this altitude. So that's our elevator. Now where is our ground? Well, our ground, if we look at the triangle as the big triangle, our ground is always the hypotenuse, so it's always this side. So here we start at this corner. We go inside the building, which is 36. Then we go up the elevator, which is x. Go down the elevator, which is also x, and then outside the building. But here we're not given explicitly what this outside the building length is, right? So we have to find it. Well, they give us the total length of the hypotenuse, which is 100, and then they give us this 36. Well, to find what's left over, we would subtract them, so we would have 100 minus 36 as this length. All right, now we're ready to solve. Cross multiply, we have x squared, because we had x times x, equals 36 times 100 minus 36. Well, that would be 64. So we multiply those together. Okay, now we want to square root. So on the left, the square root and the square cancel out, and we have x. And then we look at the right. And right now I don't want to multiply because it's easier to see how we could prime factor just with these numbers. So we could prime factor 36 into 6 times 6 and factor 64 into 8 times 8. Well, look at that. We have pairs already. So we could just write them out. In the square root, 6 times 6 would just equal 6, and then we would be left over with 8 from that 64. Multiply those together, and then we get 48. All right, I would like you to try it number 2, letter A, and find the value of the indicated length, which is x. So here we would go inside the building, which is x, go up the elevator, which is 12, equal that to going down the elevator, which is 12 over 16. Then multiply. So here, because x is on top, I could just multiply by 12 on both sides. 12's on the left cancel out. X equals 144 divided by 16. And if we put that into our calculator, what would we get? We'd get 9. Okay, so hopefully everybody got that. Now let's move to letter B. Let's try it on our own first. Hopefully everybody got x equals 100. Now I have put my work here, so you could go ahead and check it.